Okay, so good morning and welcome to our Chapter 7 discussion, which is on UV spectroscopy. No? Dalawang parts to. No? So yung first part, we're going to look into the concepts behind spectroscopy itself and the different types of spectroscopy, how they were utilized, or how they are utilized by chemists, no, in order to make one quantitative and qualitative measurements, no, sa isang compound, no. And the second half is how we apply yung absorption of a certain chemical species to quantify chemicals. Okay? So yun yung dalawang parts. No? So I'll put chapters dito sa ilalim ng ating video para guided kayo kung nasang part na tayo. Okay? So yan. So again, we're going to take a look into the gist of how spectroscopy works, what we can get from it, how it is made, and how to make measurements. Now, okay. So we have several things to discuss, pero I'll try to summarize all of them. No? Yes, 73 slides yung PowerPoint, pero they can be summarized in just few seconds lang. Okay, so yan. So yun na nga yung flow natin. Tignan muna natin yung context on how spectroscopy works and then what are its parts, no? And most importantly, yung absorption law. Okay? So first, let's take a look into the historical context, no? Yung pinakaunang spectrometer natin, no? Which is called the spectroscope. Okay? So probably you've seen this sa physics textbook kasi ito yung ginamit ni Newton, no? Kaya niya nasabi na yung light gawa siya sa multiple colors, no? So yan, so spectroscope, this was used by many physicists and chemists at the time in order to identify the light emitted by certain objects. Ito rin yung ginamit ni Niels Bohr to make what is called the emission spectra. Yan yung ginamit niya in order to say na yung atoms, they are made of electrons with different energy levels or different orbits. No? So ang idea is that in a spectroscope, one can determine the wavelengths of a certain light source. No? Let's say an atom, sunlight, or anything else. No? So siya yung ginagamit check ano yung emission spectra and we use that to compare what elements are there. Ito rin yung ginamit ng mga physicists before, mga astronomer before that helped them conclude na yung sun natin is primarily made of hydrogen and helium. No? So yun yung ginamit nila. So thanks to Niels Bohr, thanks to Newton and all the other physicists, no? Na using this, nalaman nila what elements yung pwedeng mag-exist from a light source. So, given this context, no, papansin nyo na yung light, it has something to do with the identity of matter in it, no? So, it appears na kung iba yung element na nandun, iba yung spectra na makikita mo sa spectroscope, no? Siguro just to help you further visualize this, no? So sige, magtitingin tayo dito sa share ko lang. Okay, so eto, tignan nyo. So when you view your spectroscope, okay, let me just share my browser. Okay. So when you view your spectroscope, ayan siya. So ito yung nasa slide natin. Okay. So what astronomers, no, physicist views is yung ganito. Yan. Okay. And depending on the lines na nakikita nila sa spectra, they can identify the elements present in that light source. Okay? So, ganun lang. Anyway, so let's go back to the PowerPoint. Okay. So, yun yung context na. Okay? Na dati pa ginagamit natin yung light in order to make inference, no? Kung saan gawa yung mga bagay. Okay? Now, ano yung mga modern uses, no? Or modern applications ng light, no? We have this thing called the colorimeter. Okay? Saan to ginagamit? So, ginagamit to ng mga medtech in order to test yung urinalysis. Okay? May test strip doon. Tapos inilulubog nila sa ihe. And then, magbabago kulay nun. Depending on the colors, they can quantify kung gano'ng karami yung proteins, gano'ng karami yung urea, etc. No? And saan pa ginagamit yung colorimeter? Sa paints, no? So what this does, no? This is a modern instrument. What this does is it checks, no? Kung anong color yung nandun sa object, no? Mostly ginagamit to for quality assurance sa paints and quantification of chemicals present in a sample, say a urine sample, no? So colorimeter ginagamit nila. So ano pa yung mga modern versions nito? Photometer. Okay, so photometer, para siyang spectroscope, pero what happens in a photometer is that digital yung ating data. Okay, kasi sa spectroscope, titignan mo yung sa butas, no? Tapos makikita mo yung lines, no? Okay, ang photometer naman, ganito nangyayari dito. Yung photons, which is light, yung photons, they hit a certain part of the instrument that converts light energy to electrical energy. Kaya nga sabi dito, photoelectric. So when that light hits a certain part of the instrument, nagkakaroon ng electrical signal. Okay? So ito yung gamit sa chemistry, photometer. Okay? So yun. Maraming versions niyan, yun yung di-discuss natin later. Okay? So ito yung ginagamit to determine absorption, emission, fluorescence. What are those terms? Daanan natin mamaya. Okay? So photometer, tawag natin doon. When the light is converted to electrical signal, which can be interpreted with the computer. Okay? So photometer tawag doon. Meron din tayong tinatawag na spectrograph. Ako, never pa ako nakagamit na itong spectrograph. No? Well, para lang siyang spectrometer. No? Parang lang siyang ganito, but a modern version. No? Ayan. So in a spectrograph, ganun din. You have your light source. It will hit a plate, no, which reveals the spectrum. No? Parang spectrometer lang din. Okay, but a modern version. Okay. And then we have the spectrometer and the spectrophotometer. Okay. So there's a minute difference between the two. Okay. So pag sinabi natin spectrometer, so spectro, light, meter, measurement. No? So dito sa spectrometer, no, it selects a certain wavelength and mini-measure niya yung light properties doon. Yung intensity ng light, yung transmission ng light, yung absorption ng light, etc. Pag sinabi namang spectrophotometer, again, yung keyword na naman natin dito, photon, no? Yung photons, no, na nadetect ng ating detector, they are getting converted into an electrical signal. Okay? So, yan. So, anong part ba ng instrument yung sinasabi ko na nako-convert yung light into electrical energy? We call that the phototransmitter. transducer. Okay? So bigyan ko kayo ng context. Ano nangyayari sa phototransducer? Okay. By the way, again, puro context lang to, no? Puro terminologies. So, ano lang, chill lang kayo dyan. Okay. So, listan nyo lang yung mga keywords na ine-emphasize ko. Okay. So, anyway, let's go back. So, ano ba yung phototransducer? Para magkaroon kayo ng idea, no, how light gets converted into electrical energy. So, this phototransducer was actually the reason why Albert Einstein won the Nobel Prize in, I'm not sure if 1905 yan. Okay, basta nanalo si Albert Einstein ng Nobel Prize daw. Hindi na siya nanalo dahil sa special relativity or sa black hole. And then, nanalo siya dahil sa phototransducers, no, or photoelectric effect. Photoelectric effect. So, in the phototransducer, dito nangyayari yung photoelectric effect. So, ano nangyayari doon? Ang phototransducer kasi, it's like a metal surface, no? And saan gawa yung metal surface? Di sa atoms, no? And yung atoms may electrons. So, we can say na on the surface of the metal, kunwari lang to, may mga electrons travel that are there, no? Okay? And then when the light, okay, when the light hits these electrons, some of them get ejected. And yung sinabi natin ng electrochem applies here. When electron moves from one position to another, may kuryente, may electrical signal. Kaya nga yung light na convert into kuryente or electrical signal. Kasi, yung electron patalsik eh. No? So that phenomena is called the photoelectric effect, discovered by Albert Einstein. Nanalo siya ng Nobel Prize due to that. Na? Okay? So yun lang yung key idea sa mga phototransducer. That when that certain light with a certain energy hits the metal surface, the electrons on that surface get ejected. And whenever there's a movement of electrons from one position to another, may kuryente na na-generate, no? And depending on kung ano yung observe ng instrument sa sample mo, then nade-detect natin yun as an electrical signal. Okay? So, yun lang. So, medyo nag-overlap nga yung meaning ng spectrometer sa spectrophotometer. Sa lagi niyo lang tandaan, pag spectrophotometer, gumagamit siya ng phototransducer which converts light to electrical energy. Okay. So, meaning digitized yung data. While for spectrometer, usually manual yan. Ako nakagamit ako ng spectrometer. Minamanual mo yung adjustment para malaman mo yung wavelength, no? Ayun. So, ganun ginagawa namin dyan. Okay? So, yun yung mga keywords na may encounter natin throughout this chapter. What else? Ano pa yung mga concepts? Ito na. Okay. So, spectroscopy, no? Alam niyo naman yung idea na dyan, no? Na pag may OP, meaning yan ay study, no? So, spectroscopy is the study of light interaction with matter, okay? So, yeah. So, there are many types of spectroscopy or how light interacts with matter. Meron tayong tinatawag na emission spectroscopy. So, anong type ng light yung ini-study sa spectroscopy na to? Emission. Okay. So, meaning that your sample emits the light. No? So, it emits the light. No? For example, kunwari may metal ka, no? May bakal ka. Initin mo yung bakal. Anong nangyayari sa bakal? Nag-glow siya. Okay. That is called emission spectroscopy. Why? Kasi yung heated object mo, nagre-release siya ng light. It emits, no? And by quantifying that emitted light, you're doing emission spectroscopy. Okay? So yun na yan. Okay. So for example, this is your sample, you provide energy with it using thermal, electrical, or chemical energy, mag-glow siya. Emission spectroscopy. At alamin mo lang kung ano yung properties ng emitted light. Okay? So emission spectroscopy. Meron din tayong tinatawag na absorption spectroscopy. Okay? So sa absorption spectroscopy, ito yung ginawa natin nung experiment na wherein your sample absorbs certain light. No? Nag-absorb siya ng light. Okay? So what happens when your sample absorbs light? Ano nga ba nangyayari? So, na-excite yung electrons. Okay? So, nag-absorb siya ng light. Okay. So, yan. So, now, yung light before your sample absorbs it is greater. No? So, kunwari, naalala nyo sa data natin, yung sa 0 molar, di ba? Na copper solution. Kunwari, nung na-detect nyo to, 254 units yung lumabas sa RGB value. Pero nung nagkakaroon na ng copper sa loob, ano na nangyayari? Bumababa yung transmitted radiation. No? From 254, kunwari naging 100 na lang. What happened to 154 units? No? Inabsorb siya ng atom. Inabsorb siya ng sample. Okay? So, inaabsorb niya lang. Okay. Just like a sponge. No? So, sa sponge ka sa gitna, squirtan mo ng tubig yan, may onting lalabas. Some of it gets absorbed. No? So, by determining how much light is absorbed by the sample, you are doing absorption spectroscopy. Ano pinagkaiba niyan sa emission? Sa emission, bibigyan mo lang ng energy yung atom, siya na yung mag-glow. Okay? Siya na yung source of light. However, for absorption spectroscopy, there's an external light. May ilaw sa labas. And your sample will absorb that light. No? Okay, and then onti lang yung tatagos. Okay, kukunin niya lang yung energy doon. Okay, so maraming light. After it passes through the sample, onti na lang yung light. Okay, so yun yung absorption spectroscopy. Well, you can also do quantitative analysis here. Ano pa? Photoluminescence, no? So photoluminescence is a combination of emission and absorption. Okay? So you will have an incident radiation and then there will be a transmitted radiation. May tatagos pa rin. Pero the added thing here, the added feature is that other than allowing some light to pass through your sample, mag-glow siya. Okay? Photoluminescence. So one example here is yung mga glow in the dark. No, ayan. So nag-absorb siya ng energy at the same time nag-glow din siya. Okay? So ayan, photoluminescence. Okay? So yun yung tatlong uri ng spectroscopy. We have emission spectroscopy where the energy is put into your sample and your sample becomes the source of light. Then you have your absorption spectroscopy where yung sample mo, kukuha lang siya ng energy. So yung incident light mo, after it passes through the sample, onti na lang yung light na makukuha mo doon. Okay? And then lastly, the photoluminescence. So may mag-absorb siya ng energy and that energy absorbed gets released as well. Okay? So nag-glow siya, glowing in the dark. Okay? So yeah. So that's photoluminescence spectroscopy. Similar to with absorption kasi meron kang incident radiation. Okay? But this is different than emission. No? Just may na-emit kang light pero tandaan nyo yung emission, walang light source. No? You just add energy to your sample. Sa absorption kasi and photoluminescence, dapat may light source ka for it to happen. Okay? So, yun yung mga minute differences among this spectroscopy. Now, So, bigyan ko kayong context. So, ano yung pinaka-terms namin dito in chemistry? So, some of the emission spectroscopy, tawag namin dyan ay atomic emission spectroscopy. Pag absorption spectroscopy naman, dyan papasok yung UV-vis spectroscopy, pati yung atomic absorption spectroscopy, AAS. No? Dito naman sa photoluminescence spectroscopy, dito papasok yung fluorescence spectroscopy. No? I never tried that. No? Hindi ko pa siya nag-try. So, na-try ko lang is yung UV-vis pati absorption, atomic absorption spectroscopy. Okay? Anyway. So now, alam niyo na yung difference ng tatlo. Now, let's look into the parts. No? So, tandaan nyo, pag sinabi absorption spectroscopy, there's a light source. No? Okay? So, may light source that will pass through your sample. Okay? May light tatama sa sample mo. And then, once that light passes through your sample, yung sample mo, i-absorb niya yung ibang light. So, onti na lang yung tatagos. Okay? But, ganito. No? In absorption spectroscopy, between your source and the sample, there's a wavelength selector. No? So, yan. Bakit may wavelength selector? Well, ang ginagawa namin talaga in real life is we determine at what wavelength will the absorption be maximum. Okay? So, kasi, di ba, iba-ibang wavelength, iba-ibang energy. So, inaalam namin ng mga chemist, physicist na kung saang wavelength siya mas mag-a-absorb ng light, na kung saan siya mas nagre-react with. Okay? So, before your light passes through your sample, there's a wavelength selector just for the purpose for us to determine kung saan siya mas interactive with the light. Okay? So, light source will pass through the wavelength selector and will pass through your sample. And then after that, may detector, of course. No? So, may detector ka para malaman mo how much pass through. No? Kunwari, 100% dito, pagdating dito, ilang percent na lang yung lumabas. No? And in that detector, it's getting converted into a signal. Okay? Probably using a phototransducer. Okay? So, ganun lang. So, in absorption spectroscopy, it's linear. Kaya kung makakita kayo ng absorption spectroscopy, okay, ano siya? Isang long box. No? Siguro pakita ko sa inyo sa Google. Wait lang. Hanap ako. So, okay. So, this is one example of absorption spectroscopy. Mahaba yan. Ha? Ito, nakagamit na ako na ito sa Lasal. No? Yan. So, this is absorption spectroscopy. So, there's a light source here. There's a wavelength selector here. And then it will pass through your sample. Okay? Nakita niyo yung nag-glow na yan. Yan yung sample. And then yun yung detector. And then it's displayed as a signal in a computer. Okay? So, mahaba yan. No? Parang isang desk yan. No? So, ganun siya kahaba kasi nga based on the structure that we saw here, siya ay linear. No? Dire-diretso yan. Source, wavelength selector, sample detector, and then yung signal processing. So, isang straight yan. Now, ano naman yung fluorescence spectroscopy? Sa fluorescence naman, ganito. Di ba? Yung absorption, isang straight yan. Na? Pero kapag yan, fluorescence, naka-pa-L. Kaya itong mga fluorescence spectroscopy instruments, usually square yan. Na? Nakakita na ako nito sa Ateneo pero di pa ako nakagamit. So, square sila. Kapag absorption spectroscopy, rectangle. No? Kasi nga, isang buong straight lahat yung configuration niya. Okay? Pero kapag fluorescence, square yan. Kasi may 90-degree angle yung sample, detector, and yung light source. Okay. Bakit ganito? Okay, ganito kasi. Okay. In fluorescence spectroscopy, tandaan nyo, dalawa nangyayari dito. Your sample absorbs the light and at the same time, it emits the light. No? Nag-absorb siya and at the same time, ini-emit niya, ina-absorb niya. Okay? Iba yon sa nagpa-pass through. No? Yung tinatawag natin transmitted radiation. Ano ba yung gusto i-measure ng fluorescence spectroscopy? Ang gusto niyang i-measure kasi is yung luminescence, no? Kung gaano nag-glow yung isang atom, no? So, yan. Yan. So, yun lang yung difference niya. It's in 90 degrees kasi if yan ay naka-straight line, suppose it's a straight line, ano mangyayari dito? Maghahalo yung transmitted light pati yung emitted light, no? Okay. So, sa fluorescence spectroscopy, we want to eliminate the transmitted light. No? Kaya siya ni 90 degrees. No? So, at least, yung transmitted light, hindi siya madedetect. No? Ang madedetect lang natin is yung nag-glow, yung emitted light. No? Yun. So, again, ang key difference for fluorescence spectroscopy, dalawa yung nangyayari sa sample. It absorbs light and at the same time, it emits light. No? We don't want to measure yung absorb, kaya yung emitted light yung dinedetect natin. So, to measure the emitted light, we put the detector and the source perpendicular to each other. Naka 90 degrees na. Para yung transmitted light, dire-diretso lang siya sa kawalan. Okay? What the detectors detect is the emitted light. So, very similar with kanina, except that ito, lagay mo dito. Ayan. And then ito naman. Okay, so for emission spectroscopy, sabi ko nga sa inyo, sa emission spectroscopy, yung sample mo, yung umiilaw mismo. Okay? Baka nalilito kayo, sir, pinagkaiba nun uli sa fluorescence ulit. No? Tandaan nyo sa fluorescence or sa photoluminescence, there should be an incident light before it glows. No? Sa emission, energy naman. No? Hindi siya light, energy yung ilalagay mo sa sample mo. Either kuryentehin mo yon or sunugin mo yung sample, dun siya mag-glow. Okay? It doesn't depend on an external light source. Okay? So in emission spectroscopy, you have your source, your light source, which is coming from your sample. Then, diretso yun sa wavelength selector, detector, and the signal processing. Okay? So when the light is emitted by your sample, it's a spectrum. So dun sa spectrum na yon, hanapin mo yung wavelength kung saan may may detectable absorption or emission. So yan. So ganun siya. So straight line lang din yan. Okay? So lagi nyo lang tandaan, sa absorption, sa fluorescence, there is no light, so there is a light source. Sa emission spectroscopy, yung light source ay yung sample na mismo pag sinunog mo siya. Ayan. And ano pa yung key difference? Sa absorption and fluorescence, yung wavelength selector comes before the detector. Okay? Comes before the sample then. Pagdating sa emission, the wavelength selector comes after the sample or after the source. So yan. So magkatabi yung wavelength selector and detector. So bakit ko in-emphasize to? Ito kasi nasa exam. Kaya kailangan kabisado nyo yung diagram. Okay? So yan. So yun lang yung context ng tatlong uri ng spectroscopy. Ngayon, pag-usapan naman natin yung ano yung parts niya. So, ano yung mga materials na nandun. Okay. So, pag maglalagay ka ng sample, ito yung mga materials na pwede gamitin. Pwedeng lithium fluoride, pwedeng silica or quartz, pwedeng sodium chloride, okay, potassium bromide, etc. Each serves different wavelength. So, ang common na nagagamit ko is ito, yung quartz cuvette. So, pakita ko sa inyo ano itsura ng quartz cuvette. Quartz cuvette. So, dito sa quartz cuvette, yan. So, here sa quartz cuvette, papansin natin, ayan siya. So, ito yung ginagamit sa UV vis, no? Kasi it tolerates wavelengths, no, na ultraviolet and visible, no? And it sometimes work with the IR, pero not completely the entire IR range, no? So, ibig sabihin, what happens is that if you use it sa IR, you can detect signals from it, no? Okay? Kasi hindi siya compatible at that region. Pero sa UV vis region, compatible siya. Same as lithium fluoride, no? So si Corex glass, silicate glass, medyo hindi sila good for UV light, no? So hindi siya compatible. Pwede lang siya sa visible and IR, no? But shorter IR, no? For example, ito naman. So if you use potassium bromide plate, no? Pwede siya sa UV vis and sa IR, no? Okay, so it's a very long range yung kaya niya. Okay, so yun. So itong mga materials na to, they are all applicable to your cells, no? Nilalagyan na ng sample, sa windows niya, sa lens, sa mirror, monochromator, no? So remember, all these materials has to fit, no, depending on the purpose of the instrument. If you want to use UV vis, kailangan yung pasok na pasok lang doon. So you can use either this material. Sila lang yung okay sa UV vis. No? The others, hindi sila okay sa UV. Okay? Kunwari, gusto mo naman na IR yung gamitin mo. You won't use this, not this. Rather, you use KBR. So it seems na okay siya in a very long range. Silver chloride also works well in KBR, no? In IR range. Okay, so the selection of materials are very crucial in creating a spectrophotometer. Ayan. So ngayon, pag-usapan naman natin yung mga parts, no? Parang kanina lang. So kailangan tama yung glass na pipiliin mo. Tama yung material na gamitin mo. So that it allows or it is compatible to your certain wavelengths. Another consideration that we keep in mind is the light source, no? Kung ikaw ay gumagawa ng UV vis analysis, you can use the tungsten filament lamp, no? So ang operating wavelength niya is from 320, which is ultraviolet light, to 2,500 nanometer, no? Which is about infrared na rin. This is commonly used, no, sa UV vis instrument. However, the problem with tungsten filament lamp is mabilis siya masira, no? Kasi tungsten yun, no? Nasusunog din yan, no? Especially pag nabasag, no? So yan, but it's compatible. Another light source used is called the tungsten halogen lamp, no? So what's the improvement here? Sa tungsten kasi, ang problem niya is, let's say you have an oxygen here sa glass, it will burn into tungsten oxide. So ginawa ng mga physicists, mga chemists, is instead of having air here or nitrogen, nilagyan nila ng halogen. No? Okay? So nilagyan na ng iodine vapor. And by changing the atmosphere to iodine, which doesn't react daw with the tungsten, so mas sumahaba yung life ng lamp, no? Mas longer lang yung life niya. Okay? Ito kasi mabilis masira to, promise. So, but with the iodine, mas tumatagal yung lifespan niya. Okay? So, ito yung common na ginagamit namin, deuterium lamp. So, hulaan nyo ano yung deuterium. It's an isotope of hydrogen, no? So, here, dyan sa gitna, you have a deuterium. Then, pag kinuryente mo yon, it emits UV light, no? So, around 200 nanometer to 400 nanometer. If you're doing measurements sa UV lang, this is best, no? Deuterium lamp. Pero kung gusto mo ng visible, you use tungsten halogen lamp. Okay? Kasi okay siya sa visible light. So sa UV vis, ano yung ginagamit? So it's a combination of deuterium lamp and tungsten halogen lamp. No? Okay? Kasi bakit? Sa tungsten lamp kasi hanggang 320 lang eh. Pero with deuterium lamp, kaya niya bumaba up to 200 nanometers. No? So ma-extend mo yung range na kaya i-detect ng instrument mo. Ito naman, meron tayong tinatawag na low pressure mercury arc lamps. Ginagamit sa HPLC, high performance liquid chromatography. Isa siya sa mga light source doon for the detector. I never saw this kasi mercury pinagbabawal na yun. Ito, hollow cathode lamp. So this is the light source for atomic absorption spectroscopy. So hollow cathode lamps, ayan siya. So may certain elements there. For example, there's an HCl, hollow cathode lamp for silver. There's an HCl for cobalt. There's an HCl for iron. So ang nandiyan sa loob niyan ay yung metal atom na gusto mo i-analyze. Okay. Nakakita na ako na ito sa Lasal. Cute siya. Okay. So ito namang glow bar. Saan to ginagamit? No? So ang glow bar naman, so it's just your silicon carbide rod, no? Now when heated, it produces an IR light, no? An infrared light. No? So ibig sabihin, this is not compatible with the UV vis. No? So gagamitin mo to sa infrared spectroscopy. Okay? So yan. So IR light yung pinoproduce niya. Meron din tayong tinatawag na Nernst glower, which uses a combination of zirconium and yttrium oxide na. And yun, I think ito yung common na sa mga IR spectrometer ngayon. Okay. Why? Kasi it's very small, okay? And it could be heated easily, no, to higher temperature. So maliit lang siya. Unlike yung glow bar, medyo malaki siya. So yun. So, just to summarize, no? So depending on the type of spectroscopy you are doing, there's a wide range of lamp source or light source that you can use. So lagi tandaan, for UV vis, ang ginagamit parati is the deuterium lamp and the tungsten halogen lamp. No? So deuterium lamp is primarily used for UV light measurements, while the tungsten halogen lamp is primarily used in the UV vis, no? Visible absorption. Ang xenon arc lamp, ito naman yung ginagamit sa fluorescence. Nakakita na ako nito pero again, di pa ako nakagamit. So wala nga ako masyado makwento about it. No? And Nernst glower, ito yung ginagamit commonly sa IR. And yung hollow cathode lamp, yun yung ginagamit sa IR din. Sa AAS, Atomic Absorption Spectrometer. Okay? So, lagi tandaan, hindi lang glass yung important, no? One of the factors that has to be considered is yung light source, no? Because each material generates light at different wavelengths. Okay. Now, abunod tayo sa next part, di ba? After the light source, you have the monochromator. Okay. So, may dalawang terms. May monochromator, may polychromator. Well, pag sinabi mono, ibig sabihin, it will allow one wavelength to pass through. Pero kapag polychromator, it can pass through multiple wavelengths of light. No? Okay, but not the spectrum. Ano ba yung term? Pag sinabi spectrum, yung buong rainbow yan. Pero pag sinabi monochromator, isang color lang, isang wavelength lang. Pag polychromator, pwedeng dalawa, pwedeng tatlong wavelength lang. But not the entire thing. Okay? So, yun. So, why do we use monochromator again? Sabi ko nga kanina, in UV vis analysis, what we want is yung malaman natin kung saan nag-i-interact ng maigi yung sample natin. No? So we can make good measurements, no? Ng absorbance niya, ng fluorescence niya, ng emission niya. Okay? So yan. So hindi kasi pwede yung isang buong spectrum ng light yung gamitin mo. Kailangan specific wavelength lang. So we use the monochromator to adjust that. No? So ano ba itsura ng monochromator? Ayan. So ito, balikan natin yung physics natin. So one of the example of a monochromator is the prism. No? So let's say this is your light source. When it hits the prism, you can split them into colors. No? Paliitin mo yan, palitin mo yung prism, then you have your monochromator. That's in the form of gratings. No? Okay. Ayan. So kunwari, ito yung iyong grating. So iba-iba yung may jagged surface yan. So pa-zigzag yung surface niyan. And it helps selecting a certain wavelength lang. So ano yung example ng gratings sa real life? No? Example na is yung CD natin. Okay. Di ba yung CD, pag ginanon mo siya sa liwanag, nagbabago color, di ba? Minsan kulay red, minsan kulay green, minsan kulay blue. So in a way, parang may CD doon sa UV-Vis, no? Na when you adjust it, pag ginanong-ganon mo siya, nagbabago yung light that you can see, no? From red, nagiging orange, nagiging yellow, nagiging blue eventually. So, ganun. So, inside the UV-Vis apparatus, may gratings doon, no? So, yan. And it's rotating, no? So, paano yan nagro-rotate? It could be manually operated. Pwedeng i-twist mo siya so that gagalaw yung grating para magbago yung wavelength na lalabas doon. Or pwede namang, pwede namang electronic na. No? Yung instrument na mismo yung bahala mag-adjust sa wavelength. No? So, yan. So, ang common na ginagamit is the echelon grating. So, yan lang. So, ano lang siya? It's parang CD lang siya. No? So, ayan yung kanyang diagram. No? So, echelon grating yung ginagamit normally sa UV-Vis. No? Okay. Meron din tinatawag ng concave grating, but again, echelon yung madalas gamitin. No? Sa holographic grating naman, so parang echelon grating lang yan, except that mas smoother siya. Okay. So, pag mas smoother, ibig sabihin, it means onting galaw lang, kaya na niya magbago ng wavelength agad. Okay. So, sometimes, yung wavelength selector natin, nilalagyan natin ng filter in order to remove other light forms that can interact, that can disturb the measurements. No? So, parang ano lang yan, filter ng camera, may red lens, may blue lens, may yellow lens. No? So, kung ayaw mo yung blue lens mag-interact with, yung blue light mag-interact with your sample, then you put this interference filter to remove that extra light. No? So, pampa-make sure lang na hindi tatagos yung undesired light. No? Ayan. So, yun yung ginagawa niya. Okay? Meron din tayong tinatawag na interferometer. Dito naman ginagamit ito sa IR spectroscopy. No? So sa interferometer naman, so kasi infrared light na yung ginagamit and yung infrared light kasi is everywhere. Basta mainit, may infrared. No? So we use this interferometer para ma-cancel out yung environmental IR. No? For example, nasa room ka ng IR, tapos may mainit na bagay doon, kina-cancel out niya yung IR coming from that object. No? So, yan. Okay. So, yan. So, now, na-discuss na natin yung light source. No? So, ano yung mga light source na ginagamit? For UV-Vis, ang ginagamit sa light source ay deuterium, tungsten, tungsten halogen lamp. No? Sa AAS, ang ginagamit, hollow cathode lamp. And then sa IR, ang ginagamit ay Nernst blower, no? Okay. Tapos sa monochromator, lagi tandaan, gratings yung ginagamit doon. To be specific, yung echelon grating, no? So the grating helps us select the wavelength that's more appropriate in doing the measurement. No? gumagamit tayo ng interference filter para yung undesired light ay ma-cancel out, no, sa instrument. Okay? Kapag yan ay UV vis, ito yung ginagamit na filter. Ayan, absorption filter. Okay? Pero kapag yan ay IR, ginagamit ay interferometer, which cancels out the IR from the surroundings. No? Okay, so yan. So meron na tayong light source. May wavelength selector na tayo. Yung sample, yun na yun. So skip na tayo sa sample. Now we have the detector. So the detector detects yung kung ano man lumabas after the sample, no? Kasi remember, the sample will either absorb light, fluoresce, or emit light, no? Or, yeah. So yun yung mga methods niya. Pwede siya mag-absorb, pwede fluorescence, or pwede siya mag-emit. No? So now you have a you should have a detector para malaman mo how much does your atom interact with light, no? Okay. So a detector commonly used in spectroscopy is called a transducer, no? So in a transducer, lahat ng signals na convert into electrical signal. Okay? And yung ginagamit nga dito sa UV-based spectroscopy, tinatawag natin phototransducer, wherein the light is converted into electrical signal, following the principle of the photoelectric effect discovered by Einstein. Okay? So maraming detectors na ginagamit. Kung gumagamit ka ng UV-vis, ito yung ginagamit dyan. Usually ito, photomultiplier tubes, no? Pero kung ikaw ay gumagamit ng IR, ayan, thermocouples yung commonly ginagamit. Okay? So yan. So phototubes tayo. Okay? So phototubes tayo. So yung term mismo, it detects photons, no? Based on the concept of photoelectric effect. Lagi niyo tandaan, gaya nga sinabi ko kanina, when the photon hits a surface, the electrons get ejected, no? And when there's a flow of electron, may kuryente. Okay? So it completes the circuit. Parang ito yung view niya. Zoom in tayo dito. So ito yung light source, tatama siya sa metal, and that metal electron will get ejected. So when there's a flow of electron, may kuryente. Okay? So yun yung ginagawa sa phototubes. No? Ang photomultiplier tube, ito yung ginagamit madalas. No? Why? Kasi sa phototube lang, if there's a faint signal, or if there's a faint amount of photons, kung konti lang yung photons dyan, edi sometimes the electrical signal generated is too little to be interpreted by the computer. No? So that's why we use the photomultiplier tube. So basically, it's just a phototube na marami. Kaya nga may multiplier, no? So, tignan nyo. Dito, isa lang yung curve, pero pagdating dito sa photomultiplier tube, marami na. So that, let's say, there's just one photon that hits the surface. Ang mangyayari, multiple times siya tama, so it can be detected multiple times. Okay. So if you are asked, ano uli yung advantage ng photomultiplier tube sa phototube is that sa photomultiplier, the photon is detected multiple times. No? Okay. Paulit-ulit siya na-detect. Kaya lumalakas yung signal. Okay. Ano pa? We also have photoconductive cells. No? Okay. So para siyang phototube, no? But this works like parang solar panel naman siya. So it's a flat thing. When the photon hits that, no, yung electron, it flows on the surface. No? So again, parang solar panel lang. No? So this is more sensitive, pero I'm not sure if ito yung currently ginagamit na. Ako, familiar ako sa photomultiplier tube. Nakakita na ako nito multiple times. No? But photoconductive cell, medyo hindi pa ako nakakita niyan na. Okay? So para siyang solar panel. When the light hits the surface, may electron na lumalabas. No? And that electron is converted into a digital image, no? Sa computer. Meron din tayong tinatawag na photodiodes, no? And actually, ito yung nasa camera, no? Nakakita na kayo ng ano, di ba? Probably may ano kayo, DSLR, di ba? Tama ba? Digital single lens, ay DSLR, di ba? Yung nakikita yung square sa gitna doon, that's a photodiode, no? Wherein the light hits that, and then that light is getting converted into a picture, yan, by the processor, no? So, yan. So commonly yung photodiodes ginagamit to sa cell phones, no? It also works in the same principle as Albert Einstein's photoelectric effect, no? So when the light hits this, yung electron gagalaw, and your computer converts it into a data we can understand, no? Ayan. For IR, ang ginagamit thermal detector kasi infrared ray is heat, no? So thermal detectors yung ginagamit, no? So parang may ganito sa ano eh. Alam niyo yung ano, yung IR na thermometer, yung parang barel, no? Pag tinignan mo yan, 'di ba, parang hollow lang yan. Ganito yung nasa loob nun. Pag tinapat mo siya sa surface, dinedetect niya yung infrared light that's emitted by that surface. Ayun. Okay? So yun yung mga detectors natin. So again, just to summarize, so ito yung mga uri ng detectors. We have the phototube wherein the light, okay, the photon is getting converted into a flow of electron, hence an electrical signal. Photomultiplier tube, marami lang may photomultiplier siya. So maraming curves sa loob so that when your incident light hits this surface, magbabounce-bounce yun sa loob, no? Which makes it more detectable, no? So it's more sensitive. Photoconductive cells, so para siyang solar panel, no? When the light hits this, the electron flows on the surface, no? This is more sensitive, pero probably this is more expensive. No? Photodiodes, so ito yung mga nasa camera natin. When the light hits this, it gets converted into a digital signal, no? Or image, no? Thermal detector, ito yung ginagamit sa IR. Bakit? Ito yung ginagamit sa IR, but the photomultiplier tube kasi pag sinabing IR, heat yun, no? So, yun, heat yun. Hindi na siya, photons na. So, it's heat. Now, ito sa sample. So, ano yung ginagamit para lagyan ng sample? Well, you have your cuvettes, no? So, cuvettes, may bumili sa section 2 neto plastic cuvette na. So, for plastic cuvette, we can use it for a colored sample. Pero sabi ko sa kanila, if you use it sa IR, it will react with the infrared light, no? Okay? If you use it sa UV naman, edi mag-interact din yun, no? Okay? So, commonly, what we use in cuvettes are, quartz cuvette, no? Kasi sabi ko nga dito sa picture kanina, hanapin ko lang. Saan na yun? Sabi ko nga dito kanina, kung UV-vis analysis yan, quartz is the most applicable material na because it doesn't react with UV-vis, no, in these regions, no? Pero kung IR yan, pwede siya mag-react, no? Ayun. Saan na tayo? So yan. So yan yung cuvette, no? Makagamit kayo niyan. So maraming uri ng cuvette depending on the purpose, no? Commonly ito yung ginagamit namin. So open top, no? Meron din tayong tinatawag na micro cuvettes, no? Ayan, if you have very concentrated sample, we use a micro cuvette. Kung yan ay gas naman, okay? Cylindrical cuvette naman yung gamit doon. Pwede yung gas? Yes, pwede. Okay? Pero I haven't encountered all this except for the normal cuvette and the micro cuvette, no? So yan, this is used for highly colored substances. Okay? Yan. And finally, we develop our instrument, no? So again, sabi ko nga sa inyo, Ayun, so sabi ko nga sa inyo, ang isang spectrometer is composed of light source, detector, wavelength selector, no? Sorry, light source, wavelength selector, sample, detector, and the signal processing. Okay? So yan. So pag ginamit mo yung lahat-lahat in a proper configuration, then you can detect your sample. You can identify them, you can quantify them. Okay? So ano yung uri ng mga UVs, no? Yan. Nadoble lang yung slide, sorry. So yan, so we use a spectrophotometer, no? In UVs, no? Wherein the photons are getting converted into an electrical signal, no? So yan, so saan ginagamit yung UVs, no? So it's used in chromatography, electrophoresis, immunoassays, and continuous flow analysis, no? So sa chromatography, yung detector yan yung ginagamit if mag-elute na yung substance, no? Especially for colored compounds or those with chromophores, no? Or continuous bonds, continuous pi bonds, no? Chromophores tawag doon. So sa mga immunoassay naman ay yung mga tinatawag nating na ano tawag doon? Yung ELISA, no? So ang ELISA, ganito itsura niya. So hanapin ko lang. So ang ELISA, ito itsura niya. So gumagamit siya ng parang UV-Vis din, no? So yan. So it's used in biomedical research, no? Especially enzyme kinetics and such, no? Hindi pa ako nakagamit nito na. Okay, pero meron yan sa Ateneo. Meron ba nito sa FAU? Di ko sure, no? Kasi kung meron, gagamit tayo. Kaso wala ata. So di ko sure. Okay? So yan. So maraming uses yung UV-Vis. No? Okay? So ito yung pinakaunang version ng UV-Vis. Meron pa na ito sa Ateneo and it's still working. Kasing edad ko siya actually. 1998 yung single beam photometer doon. Okay. So as you can see, it's a rectangle, Y. So yung light source, andito. Ito yung wavelength selector, this is your sample, andito yung detector, and it's getting converted into a signal here. No? So yan, kaya siya pahaba, no? Kasi naka-linear configuration lahat. And sabi ko nga sa inyo, yung wavelength selector, ina-adjust yan either manually or electronically. No? So sa photometers, ikaw mismo yung mag-a-adjust. No? Yung mga echelon grating dyan. Ina-adjust yan, tinatwist yan, and then yung grating, mag-change ng angle. And as it changes the angle, ibang wavelength yung magpapass through sa sample. Parang CD lang. When you change the angle, ibang kulay yung nakikita nyo. Okay? So yan, yung mga single beam UV-Vis, okay naman sila. Okay naman. Although they are not very sensitive na. Ito medyo marami na ngayon decimals ng absorbance dito, no? 3 decimals. Yung nasa Ateneo, ano lang 2 decimals. No? Yan. Meron din daw nito sa Lasal, no? Pero di ko pa siya nakikita. Okay? So yan. So ito medyo modern version ng single beam. Okay? UV-Vis na yan. Nakagamit na ako ng ganito sa PUP dati. So single beam lang yan. So isa-isa mo ilalagay yung sample. Meron din tinatawag na double beam, no? So kasi ano pinakaiba ng single beam sa double beam? Well, yung single beam, single sample lang pwede mo ilagay. So isa-isa mo ilalagay yan dyan, which is nakakatamad, no? So double beam, dala-dalawa, na. So at least hindi siya nakapagod. At the same time, yung double beam, it has a reference cell, no? And yung reference, always sinusubtract siya sa sample just to remove the fluctuations in your measurement. No? So yan, so yung advantage ng double beam. Okay, so na-remove yung fluctuations sa measurement mo. So ito yung single beam, kaya siya rectangular kasi dire-diretso yan. No? Your light source, your monochromator, your sample, your detector, and then your signal transducer. Pero pag double beam yan, you have your light source, this is the monochromator. Whatever wavelength is produced here in the monochromator, it's split into two, the reference and the sample set. And again, ano yung advantage ng double beam? Ang double beam ay always sinusubtract niya yung measurement ng sample sa reference so that if there's abrupt changes in the environment, nakaka-cancel out yan. Okay? So ano yung mga abrupt changes in the environment? Yung humidity or yung fluctuation sa electrical signal. So nako-correct niya yung sarili niya. So this is more sensitive. No? So gano'n ka-sensitive? Up to 5 decimal places yung kaya niya. No? Na measurement. Unlike kapag mga single beam, 3 lang. So meron din double beam and time. Ako di ako familiar dito. Pero ang idea lang dito is that yung ating mirror dito, umiikot-ikot siya. So minsan yung light pupunta sa reference, minsan mapupunta sa sample cell. No? So instead of splitting yung light source, umiikot-ikot yung mirror dito. It causes the light to either go to the reference or to the sample. So, never ko ba nagamit to? Okay, so again, UVBs, saan ito ginagamit? Sa mga chromophores, mga compounds with double bonds, and visible compounds, yung mga colored compounds. Meron din tayong tinatawag na IR spectrophotometer. Spectrometer siya actually. So yun, so ito naman, ginagamit to instead of quantifying chemicals, no, we use this to identify the bonds, no? Okay? Ito pala, kwentuhan ko muna kayo. By the way, tatapusin ko yung first part na rin. Kwentuhan ko kayo. Sa tingin niyo, bakit umiinit yung pagkain sa microwave? Bakit? Kasi, when you put your food in the microwave, yung mga chemical bonds doon, no, as they are subjected to microwaves, which is a literal wave, no, IR wave, no, what happens is that gumagalaw-galaw yung molecule mo. As the molecule moves, it creates friction, which generates heat, no. So that's why yung food, pag nilagay mo sa microwave, gumagalaw yung mga atoms, gumaganon-ganon sila, and then nagpa-vibrate sila lahat, which produces heat, no. So sa IR, ganun din ginagawa niya. Okay? So yung sample, dadaanan mo ng infrared waves, and then yung bonds nun, gagalaw-galaw. So depending on the type of the bond, iba-iba yung characteristic na galaw nila. And chemists interpret this as this. No? It appears as this graph, yung galaw-galaw ng atoms doon, iba-iba. So probably familiar kayo sa lecture sa mga wagging, scissoring, no? Out of plane, asymmetric wagging, stretching, etc. So yan, nakikita namin yun as this. And this can be interpreted as parts of the molecule. So bigyan ko kayo example kung saan ito nagagamit. So post ko muna ito. Okay, so this is one example of the IR spectra na sinasabi ko sa inyo. So ito, isang thesis paper to ng mga bata. Pero ako yung nag-interpret ng IR. So yan. So, ito yung sample nila. Ano nga ba yung sample nila? Kalimutan ko. Ito, plant crude extract na whatever that is. No? So, yung plant crude extract, nira nila sa IR. So, ano yung purpose? To identify yung mga galaw-galaw ng bonds. No? And depending sa galaw ng bonds, iba-iba yung meaning nun. For example, ako as a chemist, kayo, probably as a student, nakikita nyo na wavy lang, no? But me as a chemist, see it as different chemical bonds. For example, this peak here is nitrogen-hydrogen bond and oxygen-hydrogen bond. This bond here is, ano ba yung bond dyan? Kalimutan. NH bond, no? No? Gumagalaw yung NH, nitrogen, hydrogen. O dito naman, sulfate yung molecule na gumagalaw dyan. No? So yan, ganun kami. And by just looking at the spectra, nalalaman namin anong bonds present sa isang molecule. Nalalaman namin kung anong group ng compounds yung nandun. For example, based dito sa peaks na to, kinongclude ko siya as chondroitin 4 sulfate, no? So, ibig sabihin ito ay isang yan. So, na-conclude ko na siya ay isang polysulfated glycans, no? So, an example ng mga polysulfated glycans, heparin, okay? Ginagamit sa coagulation ng blood, no? Yun. Collagen, no? Hyaluronic acid. So, yan. So, yun yung mga nakikita ko as a chemist, no? Yan lang. So, sa yan, no? So, yung mga squiggly lines na yan, we can interpret it as different bonds, no? As long as you know your anachem well. Okay? So, yun yung IR spectrophotometer. Dispersive IR, well, ang idea lang dito is that in the dispersive IR, yung ating light is being dispersed, no? Using this shutter. No? Ganun yung shutter. Ano pa ba? Fourier transform IR. So, ito yung ginagamit ko madalas. So, what's with the Fourier transform IR? So, ito yung kanyang itsura. It has an interferometer. So, as a purpose of interferometer, it subtracts the environmental IR signals. So, pinabawas na yung IR sa paligiran. No? So, making your measurement more accurate. No? Ayan. Okay, so itong absorption law, this will be on the second video na lang. Okay, so that's the summary. So that's it for the first part of the chapter. No? So ano yung mga ginawa natin in summary? So basically, we look into the instruments used in spectroscopy. Inalam natin yung mga components niya, how they are configured. Lagi niyo tandaan, kapag emission, walang light source kasi yung sample mo mismo yung light. No? And then that light passes through a wavelength selector, a detector, and your signal is generated using a computer. Again, ay absorption is a straight line yan. You have your light source, your monochromator, your sample, your detector, and your computer. No? Pag yan ay fluorescence, naka 90 degrees lang yan. Na? Okay, bakit 90 degrees? Kasi in the fluorescence spectroscopy, what you want to measure is the emission, not the absorption. Ayan lang. And yun, diniscuss yung mga parts ng UV spectrophotometer. Lagi nyo tatandaan na yung light source for UV is commonly the deuterium lamp and the tungsten halogen lamp. Deuterium ginagamit for IR. Tungsten halogen lamp ginagamit yan for visible light. No? If you're using atomic absorption spectroscopy, ang ginagamit doon is hollow cathode lamp. If you're using infrared spectroscopy, ang common na ginagamit doon ay Nernst glower. Okay? Ano pa? Yung material na ginagamit, it depends. No? Quartz madalas, ang glass na ginagamit for UV-Vis. On the other hand, kapag IR, ang common na ginagamit ay potassium bromide glass. No? Ano pa? So monochromator, lagi nyo lang tandaan, ang monochromator may grating. No? Jagged yung surface niya so that the light will split. No? Para siyang may mini prism, mag-split siya. Tawag doon ay echelon grating. No? And then we use filters to remove unnecessary stray light or stray light. No? Kapag IR naman, tawag doon ay interferometer. No? So filter kapag UV-Vis, kapag IR, interferometer. Ano pa? Detector. So detector natin, what they do is they convert photons into electrical signal. So that is true for phototubes, photomultiplier tubes, no? And yung mga photodiodes, ayan. Pero kapag IR naman, thermocouple yung ginagamit doon, no? Wherein the heat is converted into an electrical signal. Okay? What else? Ano pa ba? Yan. Pinag-usapan natin yung Sample, saan siya nilalagay? Sa cuvette, no? So, commonly, quartz cuvette ang ginagamit, no? Pero meron din cylindrical cuvette for gas, no? And for very highly concentrated substances, you use a micro cuvette. Ano pa ba? Naisip ko kung ano pa yun, nakalimutan ko. Detector, yun nga, photomultiplier tube, etc. And then for IR, ano yung purpose niyan? Obviously, is to detect the chemical bonds in the sample. Okay, so that's it. That's the end of the first part. So, alam ko nakapagod, so hinga muna kayo. And in the next video, didiscuss ko naman yung absorption. Okay, so see you in the next video.